Okay, so this using the Pythagorean theorem, we found 17 for the hypotenuse because we'll need that. And now notice though that this is just theta, and I want to find cosine of theta over 2. Okay, so the formula for the cosine of theta over 2 is plus or minus the square root of 1. Is it plus or minus?
Plus.
Plus the cosine of theta all over 2. And so now it's just a matter of plugging in. We've got the cosine of theta would be 15 over 17 all over 2. Okay, now if I make that a common denominator so that I can actually add them together, when I add on the top I get 15 plus 17 would be 32 over 17 over 2. Now this is 2 over 1, so I can multiply by the reciprocal, 1/2. We're all with me so far? And then we have plus or minus the square root. Now 2 goes into 32 16 times, so it's 16 over 17. And then it's just a matter of doing your, college algebra business. So the square root of 16 is 4 over the square root of 17, but then we have to rationalize. So we get 4 square root 17 over 17. And notice I dropped the plus or minus. I bet you anything if we look in there it doesn't say anything about it. Oh well. Anyway, it's just a random triangle. We're not going to worry about positives and negatives for this one. Plus, besides that, we're talking about an angle cut in half. So really, it's not going to be negative, right? Still within that same positive sector. So 4 square root 17 over 17. Formula with me. So the formula for the tangent of theta over 2 equals
1 minus cosine u over sine u.
Okay. So that's what we'll use then to find the tangent. Question?
Which one do we use when we're looking at the formula sheet? Because there's like 3 or 4 different.
Pick one. Okay, so the question was, which one do you use? Because there's more than one. You just pick one. On this, sometimes it's better to pick other ones depending on what your problem is, but for this, we'll just pick one. So we get 1 minus the cosine is 15 over 17 over the sine, which is 8 over 17. And then it's common denominator time, right? So we have to get 17 over 17. We're subtracting this time, so it'll be 2 over 17 over 8 over 17. The 17s cancel, right? So we get 2/8, which is 1/4.
What?
So we're on page 257, number 49. I found negative 12 by using the Pythagorean theorem, and it's negative because I'm in the second quadrant, and x is negative there. Okay, apparently that the formula for sine of u over 2 is plus or minus 1 minus cosine over 2. And so now it's just a matter of using, because now I have the angle u, I can use triangle for u. I could not use it here because this was u over 2, and this is just u. So back to here, let's start solving. We got 1 minus the cosine of u is negative 12 over 13 all over 2. So we get plus or minus the square root of 1 plus, this will be a plus, right? And then I have to get a common denominator, 13 over 13. So that'd be 25 over 13 over 2, which is 2 over 1. So I can multiply by the reciprocal. Am I going too fast?
No.
No? Okay.
It's on video.
Plus or minus, it does matter. I want you to keep up with me here.
Well, I'll just watch the video.
Okay, so on the top, 25 times 1 is 25. 13 times 2 is 26. All right, now we've got a problem, don't we? We've got to rationalize. We've got plus or minus. The square root of 25 is 5 over root 26. So then we rationalize. Plus or minus 5 root 26 over 26. And we need to figure out, is this going to be positive or negative? You know what we could do to figure out if it's positive or negative? I could set up that sine inverse of 5 over 13 equals...
Thanks a lot, you stupid book.
Let's not do sine inverse, because sine, it wouldn't be in the second quadrant. Let's do cosine inverse. Let's do cosine inverse of negative 12 over 13. That'll tell us what angle that is, won't it? So cosine inverse of negative 12 over 13, it tells me it's 157. So if I divide that by 2, I get 78. So what quadrant is 78 in? First quadrant, right? So it's 78.69 or something like that. So what that means is everything's going to be positive. Okay, so there's sine. Now cosine, and I have to go to a whole nother page here. Okay, here we go. Cosine is going to be, then using the formula, is going to be, it'll be positive already, we know that. 1 plus cosine, is this a plus 1? Of u over 2. And so as we do this, we're going to go 1 plus, the cosine, if I remember right, was negative 12 over 13.
Yep.
Over 2. So this will be a minus, and then this will be 13 over 13. So we get the square root of 1 over 13 over 2 over 1. Two fractions and a fraction, right? Multiply by the reciprocal, 1/2. So then we get the square root of 1 over 26. Square root of 1 is 1. The square root of 26 is the square root of 26. Rationalize. Square root of 26 over 26. All right, now for tangent. Time out. It's what?
You pause.
I did not.
No pause.
Oh. Okay, so tangent, give me one of the formulas for tangent.
1 minus cosine u over
1 minus cosine u over sine u.
that one.
Okay, so we get 1 minus, the cosine of u was negative 12 over 13. And the sine of u was 5 over 13. So the 2 minuses is a plus. And this would be 13 over 13. We should be getting pretty comfortable with that, right?
Yeah. Can you cancel 13s early?
No, don't until this point.
Okay. It's just too confusing.
Yeah, you could make a mistake. So then the 13s cancel out, so you get 25 over 5, which is 5. So we're supposed to solve for x, but the big problem I have is that sine of x over 2. So I am going to, let me get a different color here.
Orange.
Not orange.
Pink.
I don't know what I want. We're wasting a lot of time on picking a color.
Purple.
Let's just go blue. Okay, so sine, I can replace that with plus or minus the square root of 1 minus the cosine of x over 2. Did I do that right?
Yep.
Okay, minus the cosine of x equals 0. And so now, whenever you have a problem with a square root in it, you get the square root by itself. So we have plus or minus the square root of 1 minus cosine of x over 2 equals the cosine of x. And then, to solve this, we'll square both sides to get rid of that square root. When we square it, we get rid of the plus or minus, and we get rid of the square root. So we get 1 minus the cosine of x over 2 equals cosine squared x.
I think there was squaring that happened somewhere.
Okay, now I want to get rid of the 2, so we multiply both sides by 2. So we have 1 minus cosine x equals 2 cosine squared. And then I'm going to move all this business over, right, to this side.
Yep.
So then we'll have 0 equals 2 cosine squared plus cosine minus 1. So then we'll double bubble, because obviously that's what we should do when you have cosine squared and then cosine, right? And we got 1 and a plus and a minus there, I think will work. So this is where you could use a box if you're not sure.
Kaylee, it's nothing to get that mad about, holy crap. Yeah, everybody did TV.
So now set each one equal to 0. And solve. So cosine of x equals 1/2 and cosine of x equals -1. And then it's a matter of using your unit circle and figuring this one out. So cosine is the x value equals 1/2. That's going to happen there and there. So we've got x equals pi over 3 and 5 pi over 3.
Well, that's not what we did.
And then -1 is going to be right there, which is pi. So once again, we're solving for x. What is the formula? Give me a... Okay, now this is where the different formulas for tangent could actually make a difference. So what are they? We've got 1...
There's one that's
1 minus cosine of x over sine of x. Is that one of them? What's another one?
sine over 1 plus cosine.
And it's just 2 of them?
And then the other one is the square root of 1 minus cosine.
We won't do that crazy one. All right, so let me think ahead a little bit. Ish. I'm gonna try this one here and see how that goes. So I'll replace tangent with that one.
It wasn't.
And then, should we get a common denominator maybe? So this is over 1. Oh, that's nice. This is over 1. So then I multiply top and bottom by sine. So now I have 1 minus cosine x minus sine squared x over sine equals 0.
Yep.
Okay. If I multiply both sides by sine, I get 1 minus cosine x minus sine x squared x equals 0. Okay, what do I do now when I have a cosine of x and then a sine squared?
Identities.
The identities. So I believe, if I remember this right, sine squared would equal 1 minus cosine squared. So I will replace sine with 1 minus cosine squared. And then to do this appropriately, we need to distribute the negative. And the 1's cancel out. So now I have cosine squared x minus cosine of x equals 0. Factor out a cosine. Take each one, set it equal to 0. X equals 0 at pi over 2 and 3 pi over 2. And then here it's saying cosine of x equals 1, and that happens at 0. I feel like I did that at one point, but...
So I didn't think we did 62. I said 60. I had 60.